it like this here. So which particular point will be in, okay, I'll follow the diagram. Get into this one here. See, there's whole question, the diagram I'll think I'll better. And what is that horizontal track? The track is like this. Huh? Actually, I should bring one more arm. Already think we have discussed such numericals long back. It should have been like this, huh? The question. Anyway, nothing problem. No problem. Huh? Fine now. At least will you understand? So this is having radius small r, and this is capital R. So this is what that track. Chapati roller. Best example. Now let's get into the problem. Spool of a bobbin rolls without slipping on horizontal track. This is that track. Let's get into the problem. Now if telling the radius of spool is r and that of the flanges. What do you mean flanges? This is the flanges. Sir, how do I come to know? So technically, I think in books we don't, sometimes we call that as the axial shaft. Can you remember? It's a, English is not our mother tongue, no? Significantly more than r. He himself is telling more than r. So definitely that will be flange. At the some instant, speed of two diametrically opposite points on the spool are v1 and v2. Two diametrically opposite points. So where to take that one? And let me take, this is the instantaneous center. This is C. Two diametrically opposite points at an instant. So they will have a speed v1. The velocity of this will be, okay, this is v2. Let me have some triangle here. Huh? Okay, this is the center C. It is having pure rolling. Himself is telling that one. So these points, I'll call it as A. This is B. What is the speed of center of the bobbin? Is asking VC, no? But what we have information only V1, V2. VA and VB, we know that is equal to V1 and V2. Okay, how to get all the things. So first of all, where is the instantaneous center? I'll just expand that triangle. I'll just expand that. Some other colors. Okay, that the triangle is something very important. This is A, this is B, and this is point P, and this is asking the velocity of center of mass. So let's do one thing. How the velocity of this will be tangential to it. And the velocity of this will be perpendicular to line PB. Don't show vertical, perpendicular to the line PB. rough diagram. Okay, let's get into the other things. So this is R, this is R, this is also equal to R. Let me call this R1, this R2. This angle, let it be theta. This angle, let it be alpha. So this angle will be theta. This angle will be alpha from the geometry. So what is theta plus alpha? So 2 theta plus 2 alpha should be 2 theta plus 2 alpha should be 180 degrees. So theta plus alpha is 90 degrees. So I am getting some right angle triangle. So then this will help us a lot. This particular triangle. So 2r whole square is equal to r1 square plus r2 square. What is V1? Now let's come for this. Where is the instantaneous center? No slipping is telling. Without slipping on, I think he has given in the question itself. Huh? The bobbin, the spool of a bobbin. Spool is what and what is bobbin? Now you have to ask questions. So there are two things are there. What is a bobbin? What is a spool? Yeah. Yeah. Now see this. So what is the spool here? This spool. Huh? That everything is called as a bobbin. Hope I think at least spool of a bobbin. Now it's telling the spool of a bobbin rolls without slipping on horizontal track. Without slipping means what should be the velocity of point P? Should be 0. Given in question. So you should not blame me, teacher. Huh? So why you are writing? In the question is given, velocity of point P will be 0. So therefore, this entire thing will be rotating with an angular velocity c, omega c. let me take omega and the center of mass, what one will have velocity vc. Okay, fine now. Now, if you come and stand at point P, because P will become instantaneous center. Again, person standing here, what he says, center of mass moving with a velocity vc, and all points are rotating about center of mass with angles to omega. You come and stand at instant center, then what you have to show? You have to show that entire omega c like this here. We have discussed enough problems. I'm taking help of that condition. So therefore, this is V1 equal to R1 omega. Let me write here only. All this is related to this theta. So what we don't know now. So finally, shall we write V1 by R1 equal to V2 by R2. So shall we substitute now? Here R1. R1, R2 is what we assumed it, no? So I'll do one thing. This is equation 1 I'll call. This is equation 2. Let me simplify for R2. Then I get equation for, because V1, V2 are unknown. V1, V2 are known, R1, R2 are unknown. Let me solve for R1, R2. Solving equation 2 and 1. R1, R2 will get expression for R1, R2. Solving 1 and 2. So 4R square equal to R1 square. What is R2 will be? V2 by V1, R1 whole square. Solving for R1. R1 will be 2V1R by root of similarly, I think I'll get expression for R2. I think I'm right. I'm proceeding with the calculations what I got it. Yeah. So I got R1 and R2. Now, what is the problem? Like what we have to calculate? We have to calculate velocity of center of mass, no? That was our main question. So now what happened? I'll get the omega. These are the equations. 3, 4, you write equation something x. So put 3 and 4 in the equation x and equation y. You'll get expression for the omega in terms of v1, or put it any one equation, no problem. Put in x, put 3 in equation x, or put 4 in equation y. Solve for omega, you'll get omega. After getting omega, we know r is given. R is what again? Root of r1 square plus r2 square. Then we'll get the velocity of center of mass. Even in center of mass in the instantaneous center, as p the instant center. So what is velocity of vc? Vc should be called r omega. Next step, I'll proceed. I think we have enough diagram. Yeah. No, put 3 in equation x. Solving that, we'll get expression for omega. Or I'll write one step. This will be v1. So the entire problem is what? Identifying what is instantaneous center is what I think the main idea of this problem. We do get deviated. That's why this problem will trouble us a lot. Okay, there's a value of omega, I got it. So after getting omega, then what is the velocity of center of mass? R into omega. Because at what distance the center of mass is C the center of mass. Write it here. I think that's what the question that is being asked. So this will be R. We don't know R, no? What is R? R is what we assumed it. Root of R1 square plus R2 square by 2. And what is omega? Yeah, we ended up. Oh, what I did already. No need of this one. Already we have R into. This is then. Okay, so just simplify, no? This will be root of. So this will be our answer. 1. Velocity of center of mass. Okay, fine. Next part of the problem. What is asking? Locate points on the flange that are moving vertically either upwards or downwards with a speed equal to that of center. So where do that points? That should be equal to that of center. So is it possible such a points? The velocity of those points should be equal to velocity of center of mass. So definitely what happened, I think you should locate the distance. Now where do they can be? Okay, we'll do one thing. I think you have to go back to really the pure rolling. I think this diagram. This spool on the flange is asking where the flange will come here. Flange will come here. So let's come for this. This is what the distance from. So can can we go for a point? Okay, this distance. This is r. So we have to search for at a distance small r. They will have a speed that of center of mass, no? Because all points will be rotating. Now we have to locate a point at a distance small r from the point P. And at what distance the point should be on the flange at a distance small r. And again, what is the condition is put? Moving vertically either upward or downward with a speed equal to that of center. So where do that particular points will come? I think we have to search with a circle. Nothing to do. Nobody will help us. I'll take this diagram. So we'll take it out, this omega, this V1 also. I'll bring that. And what is the method? We have brought it at all points will rotate omega. So now we have to, and what is this distance? So definitely they should have a speed of center of mass means, and that too, this is a flange, no? This is a flange. And this is spool. Okay, fine. I think everything is there in systematic order. Okay, let's come for this one. We have to search a point which will be at a distance r. Okay, what is the length of this? That much of length what pen should be there. I think I had drawn the flange a little bit bigger. So there, if you calculate mathematically, it will and slightly greater than r is telling. So that particular point what pen will come here. Means that I'll draw a triangle. Yes, you draw a triangle. That angle should be 45 degrees. I think you work out with mathematics. This will also be r. This will be r. So this angle will be 45 degrees. I think I'm and this angle 90 degrees. So therefore, what is the velocity of this point? The velocity of this point will be downward. What is the velocity of this point? Should be upward. Don't call, so some VP1, I'll call it VP2. So these are the 2 points. What is the mistake you do? You just do mistake. What is that one? So you go for locating instantaneous center. So what I've seen. So the same problem. Almost maximum students, they do mistake like this. What is the mistake? I think if you have tried this, that the mistake is what you'll encounter. So what students are, sir, we know this is V1, this is V2, then instant center. Sir, we are very good in instant center. This was the general mistake what everyone does. So this is the instant center, so it will rotate about this. Because and is telling this is V1. Then you draw a line. So this is a wrong idea. Because the question is not given like this. What is saying? The question himself is said. What is said? It will roll about the horizontal surface. So this is the instant center. You cannot shift instant center. When the question given, what is instant center? Okay, directly go for it. Rolls without slipping on horizontal track, finish over. So the instant center is this one only. You should not think here. Huh? Yeah, be careful. Sir, why can't be like this? The velocity, the omega and the velocity of center of mass such that this will become instant center. I'll take it out again. Wrong idea. Should not be shown. Fine. So some rolling problems. Still lot to. Rolling is not over. So many things can be asked. So you do take help of the mathematics. You know it. Come to this one. I think this will be the last problem. Time. Now read the question. So something, some belt is telling. So where is the belt? Cylinder via belt, electric motor. These are the 2 cylinders. They're having a mass M. A box of mass 1 kg. Where is the box? This is the box. Let me show in the diagram only, because again drawing will take more time.